So hey guys, let's try to understand this chapter called as wave optics. This particular video series is not like any other on YouTube. It helps you understand and learn concepts of physics. So let's go ahead and try to understand why was ray optics introduced in the first place. What was the necessity of introducing wave optics? See, so wave optics was actually introduced against ray optics in some sense to account for some phenomena that were not explained by ray optics. Some of the most important phenomena include interference and diffraction, about which you will be learning in later videos. But for now, you can take some simple real life examples. Let's say a soap bubble. The colors on the soap bubble remain largely unaccounted for with respect to ray optics. That is, ray optics doesn't explain why those colors are actually visible on the surface of a soap bubble. But in the case of wave optics, when you actually take the theories of wave optics, we can comfortably explain them. Not only that, many of the phenomena which cannot be explained by ray optics are quite comfortably and quite intuitively explained by wave optics. And that's the reason we're going to learn wave optics in the first place. So, an obvious question at this stage would be, is ray optics a complete waste of time? Did I keep learning ray optics just for the sake of it? No. Ray optics does work, sometimes in its predefined domains, which you're going to learn about in this chapter. So ray optics is not actually complete waste. Ray optics can be used, quite finely used in fact, in its domains. But beyond those domains, ray optics fails. And hence, we advocate the use of wave optics. So you must appreciate the efforts of scientists involved in who coined the theory of light as a ray. So let's move on to the basics of wave optics. Of course, the history of wave optics is of just matter of interest to you. There were actually two groups which were basically light as a wave and light as a particle. Light as a particle, the team light as a particle was headed by Isaac Newton, and team light as a wave was headed by Christian Huygens, who was a great scientist if you don't know him. And so finally there were many experiments like diffraction interference, which were actually not explained by the team light or light as a particle. So team light as a wave won the battle, and eventually the wave theory of light was born. So let's move on to the basic definitions, that of a wavefront. So the wavefront is defined as follows. Wavefront is a locus of all points on a wave with the same phase. Let's say this wave, for example. Let me go real quick. Let's say I've got a point A here. Let's say I've got another point B here. These 2 points are at the same distance away from the center, or away from the line, away from this line, right? Obviously. So this obviously means that they are in the same phase, that is, they are in the same position. If you are a small person right here, if you are, let's say, a tiny minute Lilliput, you wouldn't notice the difference between this point and if you see this point, you wouldn't notice any difference between these 2 points if you go to one another. That is, these 2 points are exactly identical and are said to be in phase. Let's take another point. Let's say A dash here. A dash and B dash are again obviously in phase with respect to each other, because if you again look at this point, this is absolutely identical to this point, again with no difference. Okay, with this said and done, there are 3 types of wavefront, necessarily speaking. The first one is a spherical wavefront. Spherical wavefront is a wavefront that is emanated from a source of light, which is essentially a point source. So let's say we've got a point source here, and if you've got if you are to explain the light emitted by a point source with the help of wave optics, you would account for that in terms of spheres of light originating out. So these are basically spherical wave fronts. In the case of what is cylindrical source like your tube light, it emanates cylindrical wave fronts, obviously, because if you got linear light source, it emanates cylindrical wave fronts, which are kind of like this. If you are able to envision them in 3D, it would be really good. Okay, and also the light from distant point objects, like let's say stars, are actually spherical, to be really precise, but they become almost parallel when they reach our homes, so we are not able to detect them as spherical wavefronts. That's it. So let's move on to the Huygens principle. With all this said and done, Huygens principle is basically a principle to predict the shape of the wavefront at some time t after which the wave has propagated. So Huygens principle is essentially based on two important factors. The first one is that every point on a wavefront acts as a source of new secondary wavelets. So this is the source of the disturbance, this is the first wave created, and the first wavefront, each and every point on the wavefront will act as a source for new secondary disturbances, which we'll see with the help of the second point. And the second point says that the envelope, that is the line joining all of these secondary wavelets, will give us the shape of the new wavefront. So that's it, guys. So the next thing is that to reiterate Huygens principle for you once again, every point on a wavefront acts as a source for secondary wavelets. The small things that you see right here are called secondary wavelets, and the envelope of all the wavelets, the envelope of all the line curve joining all these wavelets gives us the shape of the new wavefront at some time t. So Huygens principle is essentially based on geometrical constructions in order to predict the shapes of waves. The prediction of shapes of waves helps us to analyze different kinds of waves at different points in time, and thus helping us a great deal. So Huygens principle is in fact quite useful, considering the time at which it was coined. It was coined back in some let's say 200-300 years back, I don't know when. At that point of time, this was really creative. So I think you got the essence of this video. I hope you understood Huygens principle. Thank you guys for watching this video, and just like, share and subscribe this video, because this is a growing channel, and I'm a passionate teacher in order to kind of help you understand the basics of physics. So please support me on YouTube. I don't have any Patreons, so yeah, thank you, thanks a lot, guys.